Okay, I think I left off on number 42, find the real solutions by graphing. That simply means I'll do it, plug it into the calculator and find the zeros. Actually, I'm not going to do it because that takes too long. But basically, you plug it into the calculator and find the zeros. So, let's move on to hold on. Okay, let's move on to the long division of polynomials, number 43. I'm going to do it on a separate sheet of paper. I'm going to divide x minus 3 into negative 2x cubed plus 4x squared minus 2x plus 3. Keep in mind I would have needed a 0 if any of these had been missing. X goes into negative 2x cubed, negative 2x squared times, multiply. Negative 2x squared times negative 3 is positive 6x squared. Then we subtract. This goes away. 4 minus 6, negative 2x squared. Bring down the negative 2x. X goes into negative 2x squared, negative 2x times. Negative 2x times x is negative 2x squared. Negative 2x times negative 3 is plus 6x. Again, we're subtracting, so negative 2 minus 6, negative 8x plus 3. X goes into negative 8x, negative 8 times. Distribute, negative 8x plus 24. And then your remainder is 27. So you could either write R27 or you could write plus 27 over x minus 3. 44, x plus 4 into 4x cubed plus 2x squared minus 4x minus 2. 4x squared, multiply, 4x cubed. Okay, so 4x squared times x is 4x cubed plus 16x squared. Again, we subtract. 2 minus 16 is negative 14x squared. Bring down the negative 4x. X goes in there, negative 14x times. It gives me negative 14x squared minus 56x. Again, we subtract, which is 52x. Bring down the negative 2. So then I have plus 52. 52x plus whatever 52 times 4 is, 208. So a remainder of 206. Oh no, negative 210. Remainder of negative 210. So if I needed to write this, I could write it as minus 210 over x plus 4. Okay. Determine which binomial is not a factor. So I should actually do synthetic division here because it's good practice for synthetic division, and that's the easiest way to determine what the factors are. So, real quick, I'm just going to go on the calculator. I'm going to type in 4x to the 4th minus 21x cubed minus 46x squared plus 219. I always do that. 4x to the 4th, arrow over, minus 21x cubed, arrow over, minus 46x squared, plus 219x, plus 180. I just need 2 zeros, so then I can do synthetic division. So, second calc 0, where am I? Right there. So that 0 is 4. So the first thing I'm going to do is synthetic division with 4. So I have 4x to the 4th minus 21x cubed minus 46x squared plus 219x plus 180. Did I just do that? Oh no, I just typed it all in. Okay, bring down the 4. This 4 moves down. Multiply 16, add negative 5, multiply negative 20, add negative 66, multiply 264, add negative 45, multiply negative 180. Okay, so now I have a cubic. Remember, this was x to the fourth, so now this is x cubed. I need one more 0. So second calc 0, second calc 0. And to the left, and to the right, and 5 is also 0. So I'm going to use 5. Remember, you use what you're left with. You don't go back to the beginning. So 20, 15, 75, 9, 45. Okay, so now I have 4x squared plus 15x plus 9. I know that 4 and 5 are roots. So I know that x minus 5 is a factor. I know that. I don't know that these other three are not. I know that x minus 4 is a factor, but I don't know about x plus 4. So I could do two things. I could try to factor this. 2x, 2x, 3, 3, 6 and 6 is 12. That doesn't work. 4 and 1. 12 and 3 is 15. That works, right? 4x plus 3 times x plus 3. My outside is 12, my inside is 3. That gives me plus 15. So 4x plus 3 is a factor. X plus 3 is a factor. The only one that's not a factor is a. Okay. Okay, I'm not doing any more synthetic division. I've already done a bunch of those. Finding p of 2, that's where the remainder is the answer. So if I go 1, negative 1, 0 because the x squared is missing, negative 7, and I want to know what p of 2 is, this is the answer. If I plug in 2 for x, I will get negative 13. It's just a shortcut for plugging it in. Rational root theorem is all the factors of this over all the factors of that. That's certainly easy. Plus or minus 1, plus or minus 2. That's it, because all the factors of 2 are just 1 and 2. Third degree polynomial. Well, one of the factors is x plus 4. Another factor is x minus 3 plus I. The other factor is x minus 3 minus I. Remember that when you're given roots, if you have a complex root, the conjugate is also a root. So if they give you 3 plus I, 3 minus I is also a root. If they give you 4i, negative 4i is also a root. That's always true. Now I'm just going to multiply these two things first. First I'll distribute the negative. And now I'm going to FOIL. X times x, x squared. X times negative 3, negative 3x. X times I plus ix. Negative 3 times x, negative 3x. Negative 3 times negative 3, plus 9. Negative 3 times I, negative 3i. Minus ix plus 3 minus I squared. So let's see what we have here. We have a plus ix and a minus ix. Those go away. We have a, oh, I think I missed an I here. I did that. Yeah, this was supposed to be plus 3i. So plus 3i minus 3i, gone. So back to what I started with. X plus 4 times x squared. I have a negative 3x and a negative 3x. Negative 6x. I have a 9 and a negative I squared, which is plus 1. So plus 10. So now I need to FOIL. X cubed minus 6x squared plus 10x plus 4x squared minus 24x plus 40. Combine like terms. X cubed minus 2x squared minus 14x plus 40. It's a lot of steps, but it's all stuff that you've been doing right along, so it shouldn't be too crazy hard. Crazy hard. It's a little crazy as far as the work goes, but it shouldn't be too crazy hard. This equation has 3 complex roots. They could be all real. You could have 1 real and 2 imaginary. The bottom line is it has 3 complex roots. Find all the zeros. Okay, so let's do this. We're going to use synthetic division. We have 1, -5, -8, 40, -9, 45. I'm going to go on the calculator and find one of the actual roots. Looks like -3 is a root, just from looking at it. So I'm going to try -3. 1, -3, -8, 24, 16, -48, -8, 24, 15, -45. So one root is -3, or 1 0 is -3. It also looks like +3 might be a root, so let's try that. Yep, +3 works as well. So I went from a 5th degree at the beginning to a 4th degree to a 3rd degree. I need to do one more so I can get down to a quadratic. I could do second calc 0, but it looks like it's 1, 2, 3, 4, 5. Let's try 5. Now, all of these make sense, 3, -3, and 5, because they're all factors of 45, which if we use the rational root theorem, you know that the factors of this divided by the factors of the leading coefficient are all the possible rational roots. So it does make sense that these are possible rational roots. So I'm left with x squared plus 1. Now I know there should be 5 zeros because I have a 5th degree polynomial. I have 3 zeros, -3, 3, and 5. I now have this quadratic left over. If I solve this, I get plus or minus I. So all the zeros of this polynomial, -3, 3, 5, and plus or minus I. Now, I'm not going to do the next two because it just takes too long. If you check the answers and you didn't get the right answer, then when you come in for the final, by all means ask and I will do it on the board. But I want these videos to get done here soon. Y varies directly with x, y equals kx, and inversely with z over z. Y is 35 when x is 25 and z is 5. Well, I know right now 35 equals 5k, k equals 7. Write the equation. This is where everybody lost points on tests. You have to rewrite this whole thing with k in it. That's write the equation that models the relationship. Then find y when x is 30 and z is 6. 30 divided by 6 is 5 times 7 is 35. So y equals 35. Suppose that y varies jointly with w, y equals kw, and x, and inversely with z. Same thing. If y is 24, w and x are 3 and 12, so that's 36 times k over 6. That means 6k equals 24, k equals 4. You can do the calculations there if you don't believe me, but the bottom line is, if you have to write the equation like it says, you have to do y equals 4 times wx divided by z. Then find y when w is 2, x is 14, that's 28, divided by 7 is 4, times 4 is 16. Let me make sure I did that right. 2 times 14 is 28, divided by 7 is 4, 4 times 4 is 16, so y equals 16. Okay. This is a graph of a function. It is shifted 5 units to the right, so that's x minus 5, and down 3, minus 3. Horizontal asymptote, -3. Vertical asymptote, y equals -3. Vertical asymptote, x equals 5. So now we have 4 over x plus 8 plus 7. A lot of you guys got this wrong on the last test. You've got to know this, okay? Here we're going to factor the top, p plus 8, p plus 7 over p plus 8. Those cross off. There's your answer. Restriction on the variable, p cannot equal -8 because it would make the original problem equal to, or undefined. Product in simplest form, 4 and 10 cancel. That's probably not the easiest way. I would actually probably multiply straight across first. and then divide. 50 over 8 makes it 25 fourths. K squared over k to the fourth is k squared on the bottom. J to the third over j to the sixth is j cubed on the bottom. All right, that's enough for this section.